Gentlemen, just a few things before we get going here. You know, please make sure cell phones don't interrupt us here. And I'll introduce the panel. We've got Matt Yearling in the middle here from Pink Solutions. They're using drones, which we'll get to hear about. We've got Bruce Welty on the left, who is the chairman at Locus Robotics. And we've got Tom Galuzzo at the other end, who is the CEO of IM Robotics. So we've got two companies that have warehouses, that have robots for warehouses. And I guess, Tom, you're about to expand maybe into using robots in the store, so maybe we'll hear a little bit about that. With that, Alex, maybe you could go ahead and let's get started. Oh, I guess I do. I guess it's me. So I wanted to ask everyone on the panel how they got started. I know some of these, I know the answers to a few of these questions, and there's a couple interesting stories here. So let's start with you, Bruce.
Sure. Thanks, Steve. So we got in the business, we're sort of reluctantly. Originally we're in the warehouse business, and we have a fulfillment company called Quiet Logistics. And in 2009, we implemented a Kiva robot from a company in Boston called Kiva Systems. And we really liked it. We loved it. And we built a business around it. And it gave us a competitive advantage in speed and cost. So we were feeling pretty good about ourselves. And one day, Amazon came in to tour our building. Kiva wanted to sell them some robots. They liked it so much, they bought the company. And then they took the robot off the market. So we were stuck without a robot, and I traveled around the world to try to find one. Couldn't find one that I liked, so we built our own. And that became Locus Robotics. So that's how this company came to be.
Okay. And Pink Solutions, Matt?
Yeah, so we do have a little bit of a technical difficulty there, but that truck should not be driving off to the side there. But anyway, it's okay. It's okay. It just gives you some perspective of what we do.
Yep.
So Pink has been around since 2004. We have this core underlying platform that really identifies and locates inventory and assets, and up to about 2013, that platform was very two-dimensional in orientation. So it was locating large assets in the context of a yard operation, inside the four fences, outside the four walls. So that could be a large asset like a trailer, it could be a large asset like a finished vehicle, or it could be a large asset like anything that's wheeled, pretty much. And then some of our customers actually said, hey, if I had a different perspective on that piece of inventory, an elevated perspective of that piece of inventory, that would be kind of interesting to us. And so they didn't really say what they meant, but we thought, hey, why don't we take that same sensor platform, install it on a drone, and elevate it into the air? And what that gave us was a platform that was able to identify and locate inventory and assets in 3 dimensions. And so basically what we do is we don't move the inventory or an asset, we move the sensor platform past the stationary inventory and asset. And as we're moving around, we illuminate everything around us, whether or not that's RFID energy or whether or not that is optics, and are able to triangulate in terms of where that inventory is and pinpoint where that is in 3 dimensions. So that's kind of what we did with our aerial robot.
And IM Robotics.
Yep. So I was working at Carnegie Mellon University as a robotics researcher around 2011, 2012, and we were working on projects for DARPA, which is the research agency of the Department of Defense. And so they had this vision of how do you get robots to not only drive from point A to point B, but have the robots autonomously do something useful, by themselves when they get to point B or point A. by having them, be able to look around, see items for themselves, pick them up, grasp them, move them. So we started looking for low-hanging fruit in an industry where people are pretty much just employed as simple object movers. So I walk from point A to point B, I pick up an object, and I move it. And so we were led very quickly into the supply chain where pickers and order fulfillment workers pretty much do just that 100% of the time. And so we got really excited about that capability, and so we made a mobile manipulation robot, brought it to market, so forth.
And then the next question I asked of the gentleman on the panel is, it's never just about technology. It's how technology marries with process that really begins to bring value. Let's stay with you, Matt, and sort of describe how the technology works in a process.
Yeah, so, if you just take a macro level of just the U.S., some industry numbers are 250,000 plants and warehouses in the United States. As Tom points out, or as Steve was pointing out, you're looking at stores as well. There's about 5 million stores as well that also kind of look similar, especially in the back room. So, what we see is when we look at, and when I talk to some of the executives that are responsible for these supply chains, I ask them, percentage split between inventory in motion and inventory stationary. In motion being inventory coming into the network, going through the network, going out of the network on a vehicle versus inventory on a shelf in a warehouse or in a store. You'd be surprised to know that 90% of all inventory looks like this. And what that tells you is that people are carrying too much inventory, okay? However, people don't know where their inventory is. That's why there is 90% is on the shelf like this. So that's kind of what we focus on. The other thing that is kind of interesting when you look at those 250,000 plants and warehouses, they all look pretty similar. They all look like this. And in terms of automated storage and retrieval systems, it's single-digit penetrated in the market today as well.
Okay, so the next slide, I think.
But hang on, but if you go back, if you go back, sorry.
Okay.
But on this,
Yep.
I'm just trying to point out, we all talk about the digital supply chain. Digital supply chains, information systems
Yep.
that we think is true.
Yep.
That lacks interconnect to the physical world. So we bridge that gap between the physical world and the digital world. Today, how that's done is with people following manual repetitive tasks.
Right.
I actually hate doing that task. So this is just an example. Pen on paper, fingers on keyboards, hand scanners. This is how people today do that inventory reconciliation process. Everybody I talk to says they have 99% accuracy until you start going into the detail, and then you find out it all comes apart. Okay, so there is significant value to be had to understand where exactly your inventory is and
Well, okay, I want to push on that because I've covered the warehouse management market for a long time, and they say if you use an RF gun in conjunction with a warehouse management system, it's not 99%, it can be 99.8, it can be 99.9%.
You're absolutely right. I was in a warehouse last week and they said that.
Okay, so explain how really it's not that high.
Well, because they still lose track. They still lose track of these items, even though they think they're doing the right thing, okay?
Right.
So what happens is, sometimes they're scanning the wrong barcodes, sometimes they're scanning the wrong location. I mean, this is what you see all the time. There is process breakdown. There's a person that's handling that sensor and doing a task, and it fails, okay? So what they think is reality is not actually consistent with what is actually true.
Okay.
So even 1% improvement, by the way, is huge if you're operating at scale, right? Which is not true, right? Because it's more than 1%. Okay. So from a financial perspective, they may have high 90s, but from a location perspective, like where is it? So you don't go through a hunting exercise.
Right.
It's more than that, right?
Right. Yeah.
So this is what we are seeing in the environment as we talk to the big companies around this particular problem. So what we're talking about here is replacing, augmenting this person, by the way, not replacing this person, getting her out of a dangerous situation, getting her into an office, and that office, by the way, doesn't have to be on site. It could be thousands of miles away.
Yeah.
And for that person to operate an aerial robot, push a button, go and scan, and see the results of that scan, and do that 400 times faster than how it's done today.
Okay.
So it definitely redefines that process, and that's really what we're focused on.
Yeah, maybe I'm pushing too long on one person, but back to a warehouse management system. You've got a drone flying by the shelves, and it's taking pictures, right? If there's one box in front of another box, you know, cycle counting is at location 167, there's 3 units here.
Yep.
So can you see behind those boxes? How do you?
Well, so, so there are inherent limitations.
Yeah, okay.
So there are inherent limitations. This robot does not have arms. It can't dive into bins.
Right.
It can't go into racks, can't fly around racks.
Yeah.
But bottom line is, if you as a human can look at the inventory that's in front of it and understand what's in front of you, you can train a robot to do that.
Right.
And even understand volume, understand count, understand labels. Now, some of this, you know, is a journey, right? We're just working
Right.
on some of these things. But labels for sure is very, and you could read labels,
Right.
you're perfect.
So the low-hanging fruit is, we think we have inventory in location XYZ, but it's empty. There's nothing there.
So I was in a big warehouse last week, and that row audit of carton to bin is a big, you know, problem to them.
Right.
Even though they say that 99%
Right.
accurate. So, you know, these location accuracy is very important to some.
Right.
For some customers.
And do you find sort of inventory scattered in places in the warehouse that you didn't even know it was stacked?
Oh, yeah.
Yeah, so-
Absolutely. No, this is
Right.
what we find all the time, yes.
Okay. And then we've got Locus Robotics. Maybe, Bruce, you could walk us through how your technology works. And I think, Alex, you may have to manually start this one.
Yeah, so our robot is really in support of e-commerce and what we call each picking, which is picking a single unit. And this video shows it in a time lapse. So this is about 4 hours of work in about 1.5 minutes. And what the robots do is they work sort of like a swarm, and we have algorithms that that encourage them to cluster together so that the workers don't have to walk very far. And what we do is we put a bin on a tote on the robot, and we assign orders, and then that robot has a mission to travel through the warehouse and make stops at every location where there's a pick. And then you can't really see it very well, but when the robot is waiting for a person to help them, the lights turn green. So as you approach the robot, if it's green, you see the pick that needs to be done on the screen, you execute the pick, and then you confirm it. You have to scan it. The robot will then go off to the next pick. This has pretty much doubled productivity at every one of our customers. And we actually have very high accuracy, so we don't really need to do counting using drones. Our accuracy rate's considerably higher than 99%. And it really has to be, because if it wasn't, we wouldn't make any money. And we're audited by accounting firms every single year to prove that out. So the process here is really, what we've done is taking the robots and treated them like a swarm. In fact, we've originally called the company Locust, because the robots move through the pick space kind of like a swarm of locusts. And then we put the people on a pattern that we've worked out that looks like a surfer moving through a space. And the workers really like it. It's much less stressful. And so the other thing that's like it's a hidden benefit is, since we take out half the people, our customers take out the worst half. So not only do we get a bump up because we just have fewer people, we have a much better improvement because we actually have the better half.
So, and Bruce, if I understand this, I might be, let's see, it's Steve, and I'm in aisle 6, and I'm going to walk down to the end of aisle 6. So a bot is sitting 10 feet into the aisle, and I pick into the carton there. And then that bot may go to a completely different aisle where a different person is walking down the aisle, just to be there right in front of when they get there. Would that be a good explanation of how?
Well, we try to do that kind of optimization. It's
Yeah.
kind of funny. I don't know if you have that slide, but
Right.
you know, we studied a lot of the patterns in nature to try to figure out why, how animals behave and how things happen in nature. And so if you watch this, and sped up from looking down from above, it would sort of look like a forest fire burning through a forest, or the robots would cluster at the edge and then leave behind basically no picks, no fuel, so to speak. And the people move through in a pattern. They start at the beginning and then move to the end and then go back to the beginning. So there's a lot of interesting math in here. I mean, just what you're seeing now is called queuing. Queuing theory is quite complicated. We also solve, or at least use, we didn't solve it, but we use some of the sort of traveling salesman algorithms that are out there. And we also use some of the algorithms that people have been using to try to understand the way fish school swarming behavior. And then we use these advanced clustering algorithms, which, like I said, cause the robots to stay together. So if we can keep the robots together, we can keep the people with the robots, and they walk shorter and shorter distances. And we keep optimizing this, and you know, we're still so early on, we see sometimes improvements of 30, 40%. My previous life, for 13 years, I implemented warehouse management systems back in the 80s and 90s. And I have to tell you, when we would go into a customer, we'd say, you know, put in a WMS and your productivity will go up 15%. And generally, it didn't quite go up that much. But when we go in with this new tech and we say 100% improvement, they just don't believe us. And we had one customer say, when we showed the results were 100% improvement, she said, I can't tell my management that, they won't believe us. So this is really quite a dramatic improvement. In some cases, we're even seeing 200% or 3x improvement.
And the improvement is because there's not a lot of wasted time walking through the warehouse. Is that the main improvement in productivity?
It's productivity because the workers walk less. The picking is so much easier. They're hands-free, and they don't have to load up a rack. They don't have to start. They don't have to walk to the first pick, or they don't have to walk from the last pick. So we did some math on it, and just randomly one day, the robots traveled 50 miles cumulatively. 25 miles was spent doing unproductive things. And of that 25 miles, 15 was from induction to the first pick, and 10 was from the last pick back to extraction. So that's just unproductive work. The workers don't even know about that. They're literally just moving through this space, and they're constantly productive. And
so the workers would have had to do that unproductive labor, and now the robots do it?
Yeah.
Okay.
So half of it's gone.
Let's see if we, oh, no, wrong one. Okay. You're going to have to cue this one up too, Alex. This is you, Tom.
Sure. So with our robots, what we're doing is a little bit more focused on this dream of lights out warehousing, where machines do all the work autonomously, and you don't need as many people. So what we've done is we've made a robot that's particularly good at handling consumer packaged goods. So you can imagine, 70, 80% of supermarket items and 90% of pharmaceuticals and over-the-counter goods and so forth, health and beauty products. Our customers have, their people do about 150 picks per hour when they're in a walking and picking operation. So this is an operation where things are kind of set up like a retail store. You have these static flat rack shelves with products on them, and orders come into the warehouse either for fulfillment for online orders, or in this case, this is Rochester Drug Cooperative. They're distributing goods to mom and pop retail stores around the Northeast. Our robots we spent the better part of last year getting the robots to a viability level where they actually hit the same metrics. So we've done 150 to 170 picks per hour with our robots. And that's in a very unproductive setting because this particular customer does what's called order picking. So the robots will go out and they'll pick a full customer's order at once, and they'd be much, much faster if the robots pick 3, 4 orders at the same time, which we can do. It's just all a matter of what the customer wants. But the key challenge here was, how do you get a machine to actually see and recognize items for itself and navigate around. And so it's not intuitively obvious, but what the robot's actually doing in that little white housing on what we call the end effector, which is that red extension tool that grips the product, there's actually a camera. And so the robot is trained on what all the items look like and where they are, and it's actually trying to find the exact items in the moment. Because you can imagine when someone puts something away in the warehouse, it's not in a very precise location. They can put it 5 centimeters to the left or the right. So the robot actually needs to account for all that. And so it actually does all of the thinking, visual thinking, locally on the machine itself. And that's kind of our expertise and what's allowed us to make this possible, is that computer vision technology.
But in this case, the robot isn't just moving, it's also picking, right?
Right.
And you're using vacuum technology to do that?
Yeah, in this case, with these consumer packaged goods, we're kind of surprised. We're trying to think, what is the one gripper that's going to be applicable to the most product, right? And so most people intuitively think about a hand. And it turns out that with consumer packaged goods, there's these flat, they all have these non-porous surfaces, so it's a box or it's a bottle or so forth. And so a vacuum gripper just landed on a portion of any product, pretty much will grab it. And we were really surprised with how much we can grab. So one robot at our facility there one gripper can grab 6,000 different items. And that's the same exact gripper. And you just can't get that with a hand, because a hand is going to, people have this dexterity that robots still don't have, which allows them to kind of reach in and around things, and they can get around obstacles, and that's a really slow and complex process. But with a vacuum gripper, you can kind of just land quickly and grab a lot of products. So it actually turns out to be the most productive and the most versatile.
So there's machine learning to make sure that you're actually picking in the right location. Is there any machine learning around how much suction has to be applied to pick something that's 1 pound versus half a pound, anything like that?
No, we just size everything so that the gripper will be able to pick it. It's
Right.
pretty much just an on-off. The machine learning is mostly around identifying the correct items. So
Right.
that's the hardest part. And what we've done is, we've made sure that there's a full human-in-the-loop process to, quality check the items before they go out the door and so forth. So in e-commerce operations, that's pretty simple, right? Because every item is going to be touched when you go to pack it. So you're going to scan the items there and make sure that the robot brought over the right items.
Right, and I think you have some dimensioning technology, right, that helps with the vision recognition. Maybe you want to talk about that?
Yeah, sure. I mean, one of the themes of the conference here is digitization, and we realized very quickly that in order for robots to work like this, you really need a full digital information infrastructure of what all the items look like, where they're all kept, and where they're kept is kind of a solved problem with the WMS systems that Bruce mentioned. But what they all look like is really unsolved. I was surprised. There's no standardized global database of what every SKU in the world looks like. And so we realized pretty quickly that if we're going to get this to work, that we need to be able to induct that kind of information to our system efficiently and very accurately. Because if the robots are trained on if the wrong item, if they're trained that this item looks like a different item, they'll never find it, right? So we took our computer vision technology and we packaged it into a standalone kind of miniature photo booth, if you will, we call Flash, which is basically a scanner that if you don't have an item scanned, you can put it in one of the items in that scanner, and it'll collect dimensions and weight, and it'll collect high resolution pictures and all those things so that our system is immediately trained.
Okay, beautiful. And I think you're going to explain how drone technology works in the warehouse.
Well, it's very similar to what Tom was saying. It's all the same technology that autonomous cars use, right? So, the same thing that you were talking about from computer vision for autonomous navigation in a GPS-denied environment is the same technology to identify inventory. So it is all deep learning, optics, computer vision, whatever you want to call it. It's all optical technology for the most part.
Right.
Even though that we are doing RFID as well, but indoors, it's mostly optics is what we're talking about.
But you don't have to know what the package looks like. You just do
No.
a barcode scan.
No. So
Yeah.
today, so
Yeah.
one thing this is not strapping a barcode scanner to a quadcopter
Okay,
and figuring out and thinking that that's going to work.
Yeah.
I mean, I don't know how many times I talk to big companies and they say, yeah, we've tried a pilot, it didn't work, right?
Yeah.
We crashed it. So if that's what your expectation is of flying a drone in a warehouse, that's the wrong expectation.
Yeah.
If you don't automate this, you're missing the point. And we definitely just don't focus on the barcode.
okay.
Once again, it's whatever is distinguishing that package in an appropriate way, we will focus on.
Okay, so do you have to do what Tom does? Do you have to sort of have an item have its picture taken so that you can recognize it later, or?
So we are predominantly focused on labels that are interesting to you. Today, we predominantly focus on
Yeah.
labels.
Yeah.
And so just like you train an optics engine to understand a bottle of water, you train it to understand a label and classify that in an appropriate way.
Okay.
And determine how we want to process that label.
So it doesn't have to be just a barcode label. It could
No.
have print that says.
Yes.
Okay.
Yes, yes, absolutely right. And but we are going into the same sort of technologies, right?
Yeah.
Understanding structure, understanding the number of cartons in front of me, understanding the volume in front of me, understanding a lot of different aspects associated with what you can do in these environments, right?
Mm-hmm.
So even you can get a good trend over time in terms of your density in a warehouse, right? How dense is it being, and how has that changed over time?
Right.
So we're getting a lot of good data that can you can analyze. Well, we're not focused on the analytics, but we could definitely do that. The other thing with the optics is to bridge the gap, right, between whether or not it's a robot picking or whether or not it's a person picking with glasses. You can get that rich imagery into that experience, and actually we can provide guidance in terms of the path to that inventory. So these are all the things that we're working on with customers.
Okay.
And I think I had another slide if you go next.
Yes.
So this is actually just in our small little warehouse, just to give you an example. You can't really make it out, but really, once again, there's nobody operating this. I can launch this thousands of miles away. I can launch this on a phone. You don't have to be there. It's looking at, in this particular case, it's being trained to look at these labels. And as you can see, there's a lot of labels on these packages, but it throws out any labels it doesn't want to look at. It's only focused on specific labels. And there could be multiple case labels in that environment, but I don't think this video shows it. But yeah.
So I kind of get what you were talking about around cycle counting, right? So when you put a box away, right, you're supposed to put it in location A100. Maybe you put it in A101. And the WMS system thinks it's in a particular location. It's not.
Yeah.
But now your drone can fly around and say, this is in the wrong location.
Well, so here's what we also see
Right.
as well. And, just looking at this, people say, hey, I've tried this with a barcode scanner strapped to a quadcopter, and I get 80% read rate on the barcode. It's like, well, if you're doing indiscriminate scanning of barcodes,
Right.
that's not going to help you, number one. Number two, if you're trying to help a process that's more efficient than your scanning process, then that's not going to help you either. So the other thing is that we don't care about the orientation of the labels either, right? So, what we find is people just put a box away and, the label's like upside down or whatever. We don't really care.
Right.
Right? So this is what you can do with this technology.
Yep.
It's cool.
Yeah, and I think we already talked through this, Tom. This shows your flash, which is the technology that takes a picture of your object and says, this is who I am.
Right. Yeah, and all that data goes into our SwiftLink software, and it's really the software that enables the robots to work, because the software manages the data and the robots depend on the data, right? So the SwiftLink server it does what it sounds like it does. It connects up, it links up the Swift robots to the warehouse management system and provides and feeds the robots with all the necessary data.
Okay. I think,
We missed one?
let me see if I missed one here. So the next thing is, what is driving uptake of these technologies, right? Actually, in the case of warehouse robots, if you do market studies, the market was big, and then Amazon bought Kiva for $750 million, and they were doing about $100 million in business a year, and they stopped selling them, and the market went down. And now Bruce and Tom are trying to rebuild that market. So, so maybe we start. I guess this is Locus Robotics. Maybe you start about talking about what's going to drive your business, Bruce.
Yeah. So Kiva did leave a big hole in the market, and there are a lot of companies trying to fill that hole. And you know, we had a lot of experience with it, and one thing we liked about it was that it solved the whole problem. And so we tried to make something that was, you know, solve the whole problem for us, which, you know, we had this 1 million square feet of warehouse space with, you know, 250,000 different SKUs, and how are we going to ship all this stuff? So when we started, we actually, this is an interesting chart, and it really is easy to read, because that first year, this is a really Thanksgiving, 3 Thanksgivings. So the first year, the first pick we did around Thanksgiving, around Cyber Week. And we were averaging around 2,500 picks per month. And things were very, very slow because the robots weren't working very well, and we had to debug them. So it took us a year. And then we ramped, and you can see we had a little sort of false start. Our first ramp got us to the point where we said, well, at least we know we can do it, but we flattened out because we couldn't scale it. You know, once we got to 10 robots, a lot of the assumptions the engineers made sort of failed, and we had to rethink everything. And then when we got to where we could scale it, then the business just took off. And the blue is actually our own warehouses. Those are our affiliate company called Quiet Logistics. You can see that they're still the bulk of the volume. But I need to kind of give a perspective on that. The other companies, almost all of them are multinational, multi-billion, sometimes as much as $50 billion companies. And Quiet is about a $30 million company. So there's a lot of growth left for us. We really just started ramping this thing. And we've gone from 2,500 a month to now we're actually, this is a little bit old, this chart, we're actually doing 1 million a month now. And the sky's the limit. So this is a very big market opportunity, and people are adopting it because it just makes too much sense.
So Bruce, you had an interesting situation. When a new technology company comes around and they get that first beta customer, many of those beta customers wouldn't have been 1 year patient.
Yeah.
You had a very patient first customer because it was you.
It was us, and believe me, there's still some scars on our backs. I won't show you them, but this was a very tough thing to make work because, you know, there just is a lot of, we have 30 patents now. There are a lot of very interesting new ideas that we had to figure out. A lot of really smart people worked on this. You know, the robots have to avoid each other. They have to avoid people. Obstacles, they have to know what's permanent and they have to know what's temporary. Some of this stuff is just mind-bogglingly complicated, and the guys have figured out how to make it work. One of the things we did, I think, that makes it work is we wanted a Control-Alt-Delete feature, which means no matter what condition the robot is in, you can always kind of restart it and it'll pick up where it left off. So that allowed us to actually do the work while we figured out what the problems were. Now they really don't fail. Now we're starting to work on, you know, mean time between failures studies and design for manufacturing. And the company's evolved to become now just a normal, sophisticated manufacturing company. But in the early days, it was, you know, pretty bloody.
So let's see, who provided this slide? I Am Robotics. So you want to talk about one of your drivers, Tom?
Yeah, sure. Just general themes driving automation, you know, in the world today, logistics or otherwise. It's pretty fascinating, the macroscopic trends that are happening.
Yep.
And I think it's worth mentioning since we're all here to discuss digitalization and automation. What's happening in general, first of all, unemployment is very low in the United States, so it's naturally hard to find people. But at the same time, the demographics are changing rapidly of our workforce. So we have this new generation of folks that they've grown up in a digital world. They know how to use information technology. It's innate in their being. You know, they grew up with computers since, you know, they were babies. And so, you know, when you know how to use computers and all the efficiencies that they create for our society today, it doesn't make any sense for you to do manual labor. People are more productive in general using digital tools, right? You're more efficient, you're just deliver more value to the workplace when you can. And at the same time, so we have this new generation of folks, and every generation is accused of being lazier than the previous generation. I would argue they're not lazier, they've just grown up in a world where people need to do less physical labor generation after generation, so they're just following the natural course of progress. At the same time, you have 60 million baby boomers retiring, and they're bringing all of that natural ability to do manual work that they've been trained on with them. So compound that with the fact that e-commerce and logistics is growing by 15% every year, and you end up with, you know, a million worker shortage by 2020. So everyone in logistics is extremely concerned about where they're going to find people to do the work that they need done, and our answer is that you're not going to be able to find the people. You must automate to survive.
So I came across, it was a Department of Labor study, maybe it was 2015, 2016. At that point in time, they were saying a warehouse worker made on average close to $15 an hour. Mm-hmm. But since then, we've heard of Amazon building these million-square-foot warehouses in cities and basically soaking up the warehouse labor. So in some of these hot cities, what sort of wages are we talking about per hour? Have you heard any numbers?
So that's interesting too, because and the macroeconomists are kind of baffled by it, I think, still, with unemployment being as low as it is, wages have not spiked. Yeah. And that's a big surprise because, you know, with supply and demand, you would expect wages to go up very rapidly. But I think what's happening is automation.
Right.
Right. So as people are predicting this problem, they're starting to automate, and the folks that are automating, like Amazon, like, you know, Locust customers, like our customers, and so forth, they naturally keep wages down.
Right.
Because you don't need as many people. So they're not feeling the pain as much as they would otherwise.
And Bruce, I've heard you explain why we actually need more warehouse pickers before, going forward because of e-commerce. Maybe you could, yeah.
Yeah, so just in the big picture, if you think about the globe, there are $22 trillion is being spent on retail stores, in the retail business. And most of the expensive part of the supply chain is the pick, pack, ship, meaning taking the stuff off the shelf and getting it to your home. We refer to that in the industry as pick, pack, ship. So the number of people that are shopping at this very moment is you know, hundreds of millions, and they're all doing that for free. And then now with e-commerce coming along, we have to somehow absorb all that cost into our supply chain. It's the most expensive piece of it. And customers are assuming that they can get the same products and not pay any more. And so what's happening, I mean, we're creating cost. We're literally creating jobs that never existed before. And there's just really not enough labor in the world to do that, if you think about it.
Yeah.
So that's what's driving it. And it's really silly. I mean, if you wonder why companies like Walmart and everyone else were late to the party of e-commerce, it's because they all thought it was a stupid idea. And they're right. But unfortunately, the consumer wants it now. So if you look at most of the e-commerce businesses in the world, they're all losing money. And even Amazon is losing money. So if 33% of the industry is dominated by one company and that company is losing money doing it, what does that tell you about the industry? It's not like they're not good at it. So we have to figure this out. And right now it's a broken system. And one of the reasons Locus is, and I think IAM ultimately will win big, is because we are taking so much cost out. And our vision is that our robots could go into grocery stores and the actual picking work could be done by the shoppers that are still shopping. We could incent them to just, hey, you see this robot there, look on the screen and it's waiting for an item. Pick the item off the shelf, put it in the basket, and we'll take 5 cents off your order.
That's cool.
That will work, but we have to retrain, hundreds of millions of people. So this is a big thing, and I feel okay about it because we're like people selling to gold miners. We don't know who's going to find the gold, but we know they're all going to need a pick and a shovel. But at the end of the day, I need these companies to be successful, because if they're not successful, we're not going to sustain. So
Go ahead, Tom.
Just one point, Bruce. I love that you mentioned about not enough people to do that work. Agree 1,000%, and we realized that as well. And I actually did the math on this. So I went out and I looked at the statistics, and Americans spend about 40 billion hours a year shopping for groceries. So just groceries alone, if you take out 40 billion man hours of work out of the entire economy, and you need people to do that, there's actually not enough people working 40 hours a week in the entire U.S. unemployment pool to fill all that work. Right. So all this grand vision that we all have of we're going to get all of our stuff online someday is great, and I absolutely believe it's going to happen, but it's not going to be done the way it's done today. Because if it was, we literally would not have enough people in the entire U.S. unemployment pool to do all the work. And that's just picking. That's not all the ancillary functions of driving the material around, last mile fulfillment, and all those things.
Yeah. Just an anecdote to support what Bruce and Tom are saying. ARC is an industry analyst group, and it's a weird business model in that big technology companies, big suppliers come in and actually come to us and tell us what they're doing. We had one of the biggest cold chain warehousing companies in the world come in, and the CEO told us that 5 years ago, they had 10 applicants for every job. Now they have 1 applicant for every job. So, if somebody has a record of theft or they've had drug problems, you can't really be too picky when it's 1 applicant for 1 job. Okay, drivers for Pink.
Yeah, just to bookend that thought, because
Right.
they're completely 100% with what you just said. I mean, I don't know if it's the same code chain provider, but it's one that I talked to.
Yeah.
And their turnover is 40%, right? So, that is a big problem, right? So, and, we didn't go into the global ramifications of the labor market, but when you start going globally, then it starts to get even more scarier, right? Because the turnover is significant and you can't have process executing flawlessly globally. So these are, especially when you go south of the border and you go into Latin America. So there's a lot of problems with the labor market in general. So it does require that we focus on automation. I mean, so really when we're talking to customers ourselves, there's really just 3 key business drivers. And first of all, what does inventory accuracy mean to you? Well, so at the warehouse level, we're seeing anything between 89 to 99. At the store level, we're seeing anything between 50 to about 70. Target says they're about 85, 90. I don't believe it. And
Is this front of the store or back?
just in overall, right?
Yeah,
So I mean, it's an uncontrolled environment, right? So we
Right.
got idiots like us going around picking product off the shelf and putting it back in the wrong place.
Right.
So
right.
it's a bigger scope problem at the store. But anyway, this is really what we see, and so that is, what does that mean to your business? And it means many different things, right? So I was talking to once a supply chain officer about my wife's experience about not getting her product, and it took them 6 days to say, guess what? We don't have your product. It's like, well, you know what? That is a pretty bad experience, right? And the excuse there was we manage our inventories lean, right? Well, so we all know that people are not managing their inventories as lean as they could be. So anyway, the bottom line is inventory accuracy manifests in a number of different business problems. And what does that mean, and how do we articulate that? Number two, we just talked about that, right? It's like, how do I augment my people in doing processes, procedures, and tasks that much more efficiently, right? So we talked about twice as fast. We're talking about 300 times faster than getting a person to go around an expensive piece of equipment to be able to do that, right? And changing the whole process of how I do my task. If I can have 1 million square feet and check that once every day, rather than having certainty once a quarter, that actually is going to be interesting to me, right? And once again, it goes back to the top category here. And then finally, it's safety. So if I can remove yet another employee from an environment which, you know, in the US, I think the industry numbers are 100 deaths and 100,000 safety incidents every year. That's a big deal, right? And it depends on who you are. Sometimes safety actually bubbles up to be second on the list. Safety is a big deal, right? So as Bruce points out, you gotta have the ability to move around and not go into you know, people walking around, right? But you really want to get people out of that environment and into the safety of a back office environment where they can be managing exceptions, not managing a task, and doing that repetitively for shifts upon shifts.
Right. I have a question for the audience. How many of you have gone, either called or gone online and said, do you have this piece of inventory? And they say yes. And so you, okay, I'll go to the store and I'll pick it. And you get there and it's not on the shelf. And then someone says, well, we'll go and we'll check in the back room, and you wait around for 15 minutes and they come back and say, we can't find it. Anyone had that experience? Okay, well, that's a lot of people. So when I think about inventory accuracy, I think about a very difficult ROI bucket, which is if the inventory is not there, you may lose a customer for either forever or they just may not come as much.
Yeah.
But it's hard to put ROI on that.
Well, a lot of companies have got this, you know, they've got some modeling behind this, and that factors into the top bucket there for sure.
Right.
So yes, this is exactly the problem, right? This is exactly what, if you look at what Target's doing with their acquisitions, that's exactly what they're focused on, because everybody knows that these big companies, fulfillment isn't from a fulfillment, you know, distribution center, it's from the store, and how do you leverage that? I can fulfill from any part of my network, right? But I've got to have a high degree of certainty that that product is there.
Right.
And how do I do that? And so, you know, the beauty is, as Bruce points out, that the industry is so big that it's for players like us in the industry to be successful, because there is so many tools to do this. Mm-hmm. And for each one of us, we're overlaying technology on an existing problem, not trying to redefine that problem with like an ASRS system, right? Mm-hmm. With a huge capital outlay. We're talking about adopting a piece of, you know, small investment on an existing problem and automating that to be much more efficient. That's what we're talking about.
We may come back to ASRS is Automated Storage and Retrieval System. So a lot of material handling has been very expensive with long payback periods. And so we may come back and address the issue of flexibility here. So we've talked a little bit about global opportunities. I don't know, I guess I'll open it up. You've talked about how big the global market around retail is, and Tom's talked about the fact that there's just not enough pickers to do all of e-commerce. Any other global opportunities you guys want to talk about? I mean, I guess the hot spot for this right now is North America. We typically do technology first here, and then it gets adopted other places, right? Is that what you're finding?
Actually, there's more progressive minds outside of North America. And I bet you Bruce can second that he probably gets more inquiries from Europe and Asia than he does from the U.S. Yeah, but you know.
Yeah, we do. I get at least an email a day from Japan,
Yeah.
and I've spent a lot of time over in Asia. And unfortunately, the Chinese are really very good at stealing our ideas, and they've already cloned our robot 2 different times. Fortunately, we have, we don't think they've been able to steal our software, but I'm waiting for that day too. So we have decided strategically to stay away from China a little while. We're going to move into Japan and Europe. And as everybody knows, Europe is not one country, so you have to be a little more granular to talk about Europe, but we think it's sort of Northern Europe. The Nordic countries, the Benelux, what they call the low countries, and Germany, France, probably not Southern, probably not Italy, probably not Spain, maybe the UK, maybe England, maybe not any other parts of the UK. But we're in the middle of that. It's complicated. You have software issues, you have regulation issues, you have certifications. There's a little grandfathering you can get away with initially where you can go try stuff there, but in order to actually sell it, you have to be certified in all these different countries. I think the Chinese are it's an amazing culture. They're already sort of 5% ahead of us, for 5 percentage points ahead of us in e-commerce adoption. We're around 8%, they're around 13%. They're also already bigger, and they're growing faster. So you can't really ignore China, and they have a huge initiative in robotics. And the other thing that's sort of blows your mind is that you can actually hire a worker in Japan, in China, a white-collar worker for less than a blue-collar worker. And you may try to figure that out, but the answer is it's an aspirational culture, so the workers don't want blue-collar jobs. So they, believe it or not, even though they have low labor rates, they can get people to do this picking stuff. So China's just this massive, complicated place, and we stare at it all the time and try to figure it out. The Japanese have a huge labor problem, and they're desperate for this tech because they have the upside-down pyramid problem. If you think about the one-child policy now is in the 3rd generation, so everything's upside down. Every kid has supporting all of his parents and grandparents. So one kid supports 6 people, and that's, causing them demographic problems. And they can't do this work. They couldn't make enough money doing it to support their families. So these problems are structural, and they're deep and complex. And I think robots are going to really take off in that part of the world. They already have to some extent, but we're seeing it as a big opportunity. We're just a little slow to get there because we feel intimidated by this intellectual property theft.
Yeah, and just to echo Bruce's point, China, I've talked to one robotics company, and they've sent... Yes, absolutely. So, China specifically, I've talked to one robotics company. They've sent a robot. It came back in pieces. So, to your point, it is a bit of a challenge, and we're focused, especially in the U.S. North of the border. South of the border is actually big. In Europe, what's interesting, once again, the market's a bit different. They go higher, right? Their warehouses are taller. That's an interesting factor. We see a lot more activity in the other part of Europe, which is England, right? In the UK, they don't want to be part of Europe, so there's a lot more activity there, and we're seeing a lot more activity in the Middle East as they redefine their commerce from oil-based to being a logistics hub. So we're actually seeing a lot of activity there.
So tall warehouses, I think, would be an advantage for your technology.
Yes, absolutely,
yeah. Tom, anything?
I think these guys hit it.
Okay. When it comes to opportunities, I'll bring it up. I know I've talked to you about this, Bruce, but traditionally in logistics, in warehousing, Europe has been much more likely to put in very heavy, expensive, bolted down automation. And often a payback period of five years for that. You know, most North American companies, most English-speaking companies will not do anything over 2 years. There can be very good, if you do a discounted cash flow analysis and all your assumptions hold up, you can actually get better ROI in a longer time frame. But it's risky. You're assuming that you've built a warehouse to do 60% cases, and 3 years later you're doing 40% case picking. Or you've built a warehouse in a particular location and then somebody acquires you and they already have their warehouses and your warehouse is in the wrong location, we don't need it anymore. One of the things I like about this technology is the flexibility of it. You know, in theory, you could put these in a warehouse. The warehouse is in the wrong location. They want to close it. You march those robots onto a truck. You drive it to the next warehouse. And the risk profile of these investments just seems lower to me. I don't know if you guys want to add anything to that.
Well, I think that's by and large true, but you got to remember that with the history of automation is that anytime automation is introduced in any way, there's ripple effects, right? And the processes change around the whole system. And I think the things that people still resist are those ripple effects. So some cultures are just more willing to embrace a technology for the ROI and embrace the changes that they need to make around the automation to get that ROI. There's other cultures, there's other mindsets that resist that. So, like, just to give you an example, with our robots, someone might look at the solution and, you know, think, great, I could save a lot of money, but then, you know, if your whole job is built around managing warehouse workers, then you think, well, if I don't have any more warehouse workers, what's the point of me being here? You know, it's kind of like a natural resistance, you know. Instead, they should be thinking, well, okay, if I don't have to spend as much money on pickers, what are the more productive things that I can use my people to do to make my overall business better? And an example there would be like last mile fulfillment. You know, a big part of the cost of fulfillment, major part, is picking. If you don't have that picking cost, then you can focus on the other major part, which is last mile, and really, you know, start to get some of these efficiencies where online orders actually make sense. So those are the kinds of things.
Yeah, Matt, you?
Well, no, I talked
Yeah.
to some large companies,
Yep.
and if you extremely large companies, and if you look at the penetration of ASRS in their infrastructure, it's single digit, actually single digit meaning less than 5%, right? And it's more focused on some of the e-commerce activities. And so what that tells you, and this is fact, is that, you know, there's significant infrastructure that is installed and being installed, and it all looks the same. Now, how do you adapt your business on that type of infrastructure and utilize technology to be able to do that? That's what you're pointing out, right? And that is actually, that's fact, right? You want to extract the maximum benefit out of your environment without changing your environment, because that's hugely expensive to do, number one, hugely expensive to change, number two. So when you look at the robots, latest generation robots that Bruce and others are coming out with, it's starting to look like Kiva is dated, right? Because that is almost like an ASRS system in a different way, right? It's looking dated. Now they've got challenges. How are they going to take their business to the next level? Of course, they're looking at trying to automate the pick, but they are looking dated themselves. And I don't think that they've got 100% penetration on their fulfillment network with Kiva today, right? No. So it is interesting. So now they've oriented their fulfillment centers around a specific robot technology, but it's like, okay, now it's not flexible, adapt to take it to the next level.
Right. Anything else on opportunities, gentlemen? Okay, let's talk challenges. So One challenge has already come up, which is patents, patent infringement. I want to sort of throw something out about robot patents, maybe drone patents, and see if I'm on the right track. So let's take the Kiva robot. I think people here understand how it works. Maybe people in the audience don't. But as I understand patents, there's already been movable racks in a warehouse, and movable racks in a warehouse were presumably patented. There were robots, and they were presumably patented. And then Kiva combines robots with movable racks in a specific process. So, so you guys can come out with robots that do something a little bit different and a little bit different process, and you're not infringing patents. So am I right? Are these patents very narrow? Are you guys going to get into patent wars? How are you guys thinking about the whole patent issue?
Can I take that first? Because
Sure.
I've had patent trolls attack me. I don't know if I've had patent trolls attack
Yeah.
you, Bruce, but
Right.
Not yet.
not yet. But I can tell you this. Okay, so the way I describe it, or even look at the hype cycle, okay? From
Yeah.
a Gartner hype cycle perspective, I know Gartner is not you, but you know. Just,
Right, yeah.
All right. So when you look at the hype cycle in the RFID industry, and you know, it had to, you know, inflated expectations, and then the trough of disillusionment was very shallow. It almost killed the industry.
Right.
What people don't understand is that wasn't all focused on the unit cost of the tag. Okay, it was actually to do with all the patent activity in the industry, and the big guys really don't want to persist because it got too expensive. So, as just an example, us as a small company, our core IP, we've got a lot of RFID. We were attacked 3 times with patent trolls that had patents in possession, RFID-related patents that had nothing to do with what we did, okay? But they still went after us, and it was still easy for us to settle than to persist that whole case. What I have seen that has changed, that tells me that the patent litigation and the industry in general is going to calm down a little bit, is that whole process and the whole activity around patent trolls in general and IP in general is definitely a lot more friendlier type of environment. Doesn't mean that it's all going to disappear. So we haven't had any since. We haven't seen anything around drones that are really in conflict with what we do. Yeah. We have a portfolio ourselves, and it's very specific around what we do. Right? What our core is what we do. We don't do pick, we don't do this. We are very focused on what we do. So there's not really anybody out there that's doing the same as what we're doing, so we feel really good about what we've got. But all I'm saying is that I don't think, when you look at the hype cycle, I don't think you'll see, on this type of technology, I don't think you'll see a very shallow trough of disillusionment. I think you'll see it'll come down very slightly, and then we'll see the, you know, kind of the ongoing commercialization and adoption of any of this technology start to kick in quite nicely.
Right, yeah. Gentlemen, Bruce?
Well, so, the U.S., well, I'll say globally, the patent business is really messy. And I think that's probably good and bad. I think in order to patent something, it needs to be both new and novel. And there are very few things in the world that are both new and novel. There's a lot of smart people in the world, and a lot of people come up with the same ideas, and some people try to patent them, and the patent office is overwhelmed and generally doesn't do a very good job. This is my opinion. But generally, patents, I think, are both offensive and defensive, and I think if you're in business today, you have to have patents not only so that you can protect your ideas, but so you can protect yourself if somebody, like a patent troll, comes after you. So you at least have some cards in your hand to play. We're currently, and I think Tom is too, in a very new and novel area. Autonomous mobile robots are new, and picking arms and manipulators and end-of-arm tooling and all that is also very new, the stuff that Tom's working on. And I think that we're able to patent things because of that. Kiva, for instance, a lot of people would argue isn't really a robot. The robot the device just rolls along on the floor, goes forward and backward and spins, but the intelligence of it is all being controlled through like a ground control at an airport. There's no really great sensing activity going on. It's not doing learning, it's not doing path planning, it's not reacting to obstacles. It's just following a very specific set of north, south, east, west commands. On the other hand, our stuff, and to some extent Tom's stuff too, is literally sensing the environment and making decisions at that moment based on what it sees. That stuff is new. So there's a lot of cool technology going on there. I think that the patent business, I think the patents in our industry ultimately we'll all probably start talking to each other and saying, hey, I got this patent, you got that patent, you got any eights, and we'll just figure it out.
Another interesting thing that happened, and I think it was about 5 years ago, was the patent law switch from first art to first to file. Mm-hmm. That was a big deal, and I think it was a really good move, actually, because it makes it a little bit more clear for the patent office and for litigators in general to figure out who actually owns the patent, because it's not about who did it first, it's about who actually went through the trouble to file the paperwork, pay the lawyers, and so it brings a lot of clarity to the process, and that was good.
Okay.
Here's one final thought for you. That this is something that blew me away. But so we are running a patent portfolio at our company, and international. Kiva didn't do international patents, so they basically can't protect against India and Asia. So. How much do you think it costs to manage a patent through the life of the patent, from filing it and having research and back and forth, and then paying all the fees in all the different economies? It's over $250,000 per patent. So you got to be thinking pretty serious about that.
I wanted to go into challenges around drones. I'm going to stop this if I can. Oh, I guess it's on a loop. There was once, Dan Aykroyd was on Saturday Night Live many years ago, and he was pretending to be Julia Child, who speaks in a very high artificial voice. And he cuts his finger off, and he continues speaking about how to make this recipe. And there may be disagreement here, but when I think about drones for last mile fulfillment, I think about a drone landing on a porch and a person trying to get a package, and I think about safety issues. I think about this video. So, but you guys may disagree with me on this.
But I'll start first.
This is your territory.
I'm drone guy here, so I'll start. So drone guy here doesn't care about last mile delivery. I really don't. Yeah. So there are so many other useful applications for that technology more upstream, and that's what we're focused on actually. But having said all that, I know the companies, I know the guys that are doing this today, right? You got Zipline doing stuff in Africa, you got Matternet doing stuff in Switzerland, you've got companies unnamed doing deliveries in the US. So it is happening today. So there, and you got companies, specifically. I just remember, Dave Clark from Amazon being on stage and saying, this is recently, like 6 months ago, saying, yes, we finally delivered to less than a handful of customers in Cambridge. And it's like, well, with all that hype, you're only delivering to a handful of customers. Now, I'm sure that that's changed. Right. But there is a lot of hype around it, but there is some very specific use cases around it to specific rural areas and to specific areas where it lacks infrastructure. So there are very good reasons to do this. But to your point, when you're going to see it to your back door, it's going to take a long time, and the FAA is standing in the way of that, right? So that whole regulatory process is going to take a long time to play out, and it isn't a technology, necessarily there's some technology challenges, but it's more a regulatory challenge.
Okay.
Yeah.
I guess we can end that.
Well, so I'm sure these guys have an opinion on it.
I do.
I have an opinion. So I'm a small business, remember I have a robot company, but also a logistics company. And out of my logistics companies, I deliver 30 million packages a year. So I need you to put that in your head. And by 10:30 every morning, Amazon has done my entire yearly volume. So they'll put that number in your head. And if I had to deliver 30 million packages using drones in 1 year, I could turn the sky black. So I don't know how Amazon could possibly think about using drones to deliver products. It sort of doesn't make any sense to me at all. And just managing that many devices to do that. I mean, there's a reason we use FedEx and UPS and hub and spoke and all these little vans. I mean, this stuff is, the volumes are extraordinary. And the idea that we can do it with point-to-point drones out of warehouses, maybe in the rural Africa, yeah, but I don't see it for what we're doing in the United States.
There's some good opinions here. No, there's some real challenges. There's definitely technical challenges. There's definitely regulatory challenges. I think the regulatory environment is the primary challenge blocking this. But I do think that these kinds of things are inevitable, right? They're inevitable because we need the economies to be able to drive, you know, there's enough social pressure in the world today for what the consumer wants to happen, that it will drive the adoption of these things. I don't know how long it's going to take, right? But I do think that they're inevitable. And I do think the business models will be figured out. It's probably, I don't believe it's going to be point-to-point, robots going to land on your porch and drop something off. But I do think, you know, I can envision there's so many gas stations and grocery stores in the country that have flat rooftops. I gotta imagine that, you know, you're going to a gas station regularly with your car anyways, and they got all these flat roofs. There's probably a way to just get drones to land there and drop off packages. And then somebody's gonna make a business around, you know, having a little miniature FedEx station in a local pickup point or something like that.
Oh, that's an interesting idea. I just wanted to show the maturity curve. I'm sorry, man, I didn't put drones on it, but AMR stands for Autonomous Mobile Robots. So this is ARC's opinion of supply chain emerging technologies. We've got mobile robots right at the top of that curve. So there you go. I want to give the audience a chance to ask some questions. We've got some very smart guys here, so yep, go for it. 1 second, Conrad, can you get a microphone and I'd like to be able to capture these. Okay.
How do you turn it?
It's on.
It's on, I guess. Whoa, it's really on.
Go ahead.
How's that? I'm Dave Noller from IBM. I had a question for the drone fellow.
The drone guy, yeah.
The drone guy. So it sounds like your drones are using vision to read various types of labels on boxes. Have you found that requires any retrofitting of the way people are warehousing their goods currently, or are they already okay for that?
Well, so it's not going to, you're not going to go in and solve everybody's problem, right? So, and it's a journey for some of these. I was in a warehouse last week, and you know their expectation on how they want to apply the technology. First, they want to their specific localization of inventory is what they wanted to approach first. So it's a journey. So we can help them with that, and then we're gonna help them with some other things going forward, where they've got product on the floor. Right? How do I determine volume of product on the floor when it's pallets high and pallets deep? Right? So these are some of the challenges that some of our customers have. So no, we don't want to. The whole purpose, the whole point of this technology is, once you go into an environment, you're not going to install any additional infrastructure to make this robot work. Number one. Number two, you don't change the way that they label product. The robot needs to learn the environment and learn what it's looking at.
Well, I was thinking of something else, which is the packages have to be such that the labels are
Today, yes.
visible. Okay. Oh.
Today, yes. In 3 months' time, no.
Okay.
Right? So we can make some. We don't have X-ray vision, right? We haven't invented that yet. So we have to make some assumptions based on you know, whether or not you're on the pallets, how you're doing your SKUs, right? Are you doing mixed pallets or whatever? So there's some complexity associated with that, but we can look at structure and shape.
I see. Okay, thank you.
Yeah.
Conrad, could you?
Are you guys making your own vision systems, or are you using something like Cognex or Keyence? Is that fundamental?
Okay, so I'm going to repeat this, but in the future, we're going to try and move this around. The question was, are you guys using your own vision systems?
Yeah, that's a really good question. Yes, absolutely we are. We were working on state-of-the-art technology back when I was at CMU, and we were using a lot of, you know, OpenCV and a lot of existing packages out there and so forth. This stuff was just meant for a different problem. It was meant for 2D environments and so forth. It was way too slow. So our secret sauce is we invested heavily into, you know, developing our own 3D vision real-time analysis pipeline. And that was something that I think we had this extremely rare skill set of being able to do because of our experience at Carnegie Mellon and developing novel computer vision algorithms and so forth.
Yeah, and same here. You know, there's a lot of research, there's a lot of available work that's being done out there that you can leverage. So what we're talking about here is a lot of neural network capabilities on a GPU that is light enough and powerful enough to be put on an aerial robot. So it's very much neural networks on top of an NVIDIA GPU at this point.
And we use sort of a sensor suite. We have a 3D camera, we have two 2D cameras, and we have LiDAR. And we feed all that data into Kalman filters, and we use Bayesian inference, which is just mathematical terms. This is not new. This is what they did when they sent the rockets to the moon. So it's just using every sensor we can get our hands on to try to make judgments about what we're seeing and where we are relative to what we're seeing, and everything sort of has a purpose. The cameras, the 2D cameras, look for barcodes to help us map the space. The LiDAR looks for obstacles so we can avoid hitting things, and the 3D camera looks for close-in obstacles that are not in the field of view of the LiDAR. The LiDAR sees 30 feet, and the 3D camera sees about 4 or 5 feet. So it's all fused into this, you know, math engine. We don't use GPUs. I don't think our problems are quite as difficult as Tom and Matt's problems, because we're not actually trying to pick things up. We're just trying to position a robot within a certain locus of a destination.
A quick follow-up question on this. I assume all your systems have a map of the facility, but things can happen, right? Someone can just drop a pallet somewhere for no reason at all, which changes the map of that warehouse. How do you deal with that? Is that a tough problem, or is that an easy problem?
That's a piece of cake.
For a flying
So
robot,
loud.
yeah.
No, it's a tough problem.
Yeah.
So you know, whilst these gentlemen are working in 2 dimensions, really, well, I mean, not really, but I mean, I'm flying in 3D,
For all
and
intents and purposes.
it is pretty tough, right? I mean, you've got to, if it has to be safer than the person doing his job, and it can't introduce more, unsafe, elements into the environment. So yes, it has to have that sense and avoid capability, and it has to have, it has to have the ability to see all the way around it, and it has to be able to sense and fuse a lot of sensors to be able to understand that, hey, you know what? That pallet that's being staged to be put away wasn't there yesterday. I'm going to have to go around that. Or if something's coming at it at a rapid speed, what am I going to do? Am I going to go over it, or am I going to say, I am going to go back, right? So these are the type of decisions that you have to make, and you have to make really fast. Right?
Pallets would be the friendliest object
Absolutely.
you could introduce. Try to get the robots to work when a group comes through for a tour and a demo. That's a different story.
Yeah.
Yes, has to have all that.
Okay. Yeah, I see it. Yeah.
Hello, my name is Sabine Munch. I'm from Centec.
I just wanted to follow on what you said. I wanted to have your view of the future of sensing. What do you think you're going to need in the future? And what's going to enable your systems to be even better? What sensors are you going to look into? Because you said you're working with what's here and right now, but I'm sure you have ideas about how it's going to pan out in the future.
So if you think about it, with sensors, you could take the cheapest of webcams, right, and wave it in front of a shelf and have, you know, a 10-year-old tell you everything that they see, and they're going to be almost 100% correct, right? So the data is there, and it's there. It's kind of like the reverse Turing test. If the human can do it, you know, a machine should be able to do it because there's enough data to present the correct solution. So I don't think that more better sensors, cheaper sensors are necessarily everything. We certainly want that, right? We want better, more pristine data and everything, but the data is there. It's about the algorithms to figure it out.
Well, so I'm selfish. So faster, better, cheaper, smaller, lighter is important from my perspective. And so we use, to look at that scene, we're not using a webcam. We do use cameras that are not high grade because, you know, you're fusing a lot of different things, and so you could understand what you're using these sensors for. So I think, you know, when you look at just drone technology, it's moving faster than Moore's Law, and it's actually, for us, it's a convergence of 5 key areas coming together, right? You're going to have the frame that's being nimble enough to be able to go around this environment. You're going to have a power system for longevity of flight, whether or not that is, you know, high capacity battery or hydrogen fuel cells, which we're working on. You've got autonomous flight, you've got you know, deep learning, computer vision, and you've got edge compute. Everything's going to be computed on the edge, and then we've got a cloud orchestration platform. So all of this needs to kind of move in concert with each other. So on the specific sensor type, just to give you an example, we use a very specific 4K camera today, right? So it's about $3,000 to buy. So to be able to go up from that to an 8K is $9,000. So, you know, today perhaps we don't want to go to 8K, but within the next 6 to 12 months we will, and it will be at that $3,000 price point. This is what's going on, right? So the cost performance is going to continue to increase, and the miniaturization is going to continue to increase. On the hardware perspective, all of the advancements, by the way, are mostly software. Mostly software. The sensors are important, but it's the software that brings us all together. That's really where we're focusing most of our time on. Yeah.
Is Centec a sensor company? So I feel sorry for you. So we just want everything better, faster, cheaper, smaller, lighter, and it does seem to be going in that direction. The things that we care about, we would love to see multi-plane LiDAR. We'd love to see solid state. All of it is driven by basically what Matt said is we really want, you know, more power efficiency, so we can do the same with less power because all of our robots are battery operated. His is particularly challenging because he has to fly that battery around. Yeah. And, you know, the sensor package we have in our robots, just to give you a perspective, back in the 80s, 90s, it would have cost about $250,000. And then it went down to $150,000. And when Kiva was built, it was about $75,000. So Kiva couldn't even use our sensor package. Now we can get the whole thing for less than $2,000. And like our LiDAR, which is the most expensive element in our robot, has gone down from about $1,800 down to $800. And it's going down to $10. And that makes us happy. But at the end of the day, it still does the same thing. And we just take out whatever sensor we have and plug in a new one that's cheaper because you know, everything's abstracted now. So it's all in the software. That's where the magic is. So, you know, it's a great business to be in when your components go down in price by so much, unless you're the supplier of that component.
Can I just answer this question? We're into the development of the sensor. So actually what you're talking about, this going from very expensive to cheap, this is where we operate. So actually we're not, you don't have to be sorry for us. We're part of this. So yeah.
No,
Well, it's harder to make money if you're selling something for $10 that you used to sell for $800.
no,
Yeah,
but
but
they're going to sell 100
so
times
interesting.
more because the applications are going to explode, right, as the cost comes down. So
That was my problem with the whole RFID business was, everybody wanted a chip that cost a penny or 5 cents or something, and I kept thinking, who's going to make that thing? Yeah, but that's like banging your head against the wall, right? Why would you want to build something? I mean, you can't even make money selling gum for $1, for a nickel.
There are companies selling sweets for a cent.
yeah.
I know, but they're sweets. They're not high-tech devices that require $2 billion clean rooms.
We have a question right up here, Conrad.
Katrina Hale with 3M. Drone guy, Matt.
I don't have my name
You
tag.
should really just replace the name.
Matt.
Yeah.
So you talked about using the drones for cycle count, which makes a lot of sense. Some of our inventory is outside. How robust are the drones, and what's the extremes that...
Well, if you look at our website, you will see what our core business is. It's outside.
Is it? Okay.
Yeah.
So it does heat of the South to cold of Minnesota.
Oh, but so here's the thing, right? Outdoors, because I have my customers asking me this all the time, 99% of all customers do not need a drone outside. Our platform, you put it on a mobile vehicle that's operating that yard or facility, and we still can get everything. We don't need to elevate. We don't need to do that outside. So it depends on what your inventory is, but for the vast majority of the time, we don't put it on an aerial sensor platform outside. But we can. So we can do it. We can do it both ways. But yes, outdoors, indoors. We focus on what's inside the 4 fences of a facility, right? Our core business is actually 4 fences and outside the 4 walls. And we said what we were doing, what we said we would never do, and go inside the 4 walls, right? Because inventory. And if you look at the trailer shipments across the 250,000 plants and warehouses, there are 500 million every year. 80% of the time, they're an unhooked asset in the source of destination. Especially your facilities. I know some of your facilities. It's right next to some of my customer facilities. You have a lot of trailers outside. So, and you have a lot of product probably in those trailers. So that is what we do. That is what we do. Yeah.
So Conrad, I think we have time for one more question. I think you had one? Yeah.
Is it still, is it too early to talk about, I know we talked a lot about patents and IP protection and stuff, but I'm thinking about what you said, Tom, in the beginning about how we need to, identify each container SKU because there's no database out there. Is there collaboration between, defined areas where we can standardize? And what I'm thinking is that, you've got one warehouse that may be using robotics from one company, one using another, and they're both coming up with different ways to identify the same products. You know what I mean?
So I'm sure there's some level of something going on out there, but as a general rule, no. There's not a level of enough collaboration happening to standardize on those kinds of things. By and large, because it hasn't had to happen, I think. But and Bruce, you know this from the WMS world, that you would think there would just be 1 or 2 key players in WMS. I mean, how many WMS players are out there?
Last we counted, there were 70.
There's not even a standardized, and even amongst, and every major corporation in the room, can tell you that they might have 10 different warehouses, and each warehouse in their enterprise might be running a different system. That's very, very common. So I don't know what the driving factors will be to standardize on some of those things. Maybe it's automation, and that'll be required someday. We certainly hope so. I have a vision that, initially our flash scanners will be in the warehouses, and they might progress upstream to, the enterprise, or the retail store, and then ultimately I would like them to be in manufacturers so that Procter & Gamble, for instance, could scan each SKU that comes off the new SKU that comes off the assembly line, or anytime they change a package, which happens all the time. And as soon as they do, all of the robots in the entire U.S. supply chain would instantly know how to recognize that SKU. That's kind of the grandiose vision.
Are you thinking about GS1?
I'm thinking, you're reading my mind.
Okay.
I'm thinking even a schema.
Okay,
for how
yeah.
you describe a package.
So, yeah, would you explain to the audience what GS1 is and how you're thinking it might expand?
Oh, the barcode, right? Or an RFID tag with
Well,
EPC. Oh, I'm sorry about that. But I mean, the barcode.
So
That's how we describe, that's pretty universal, right?
Yeah.
So the only initiative that I'm aware of, and that you may be aware of, is the smart label. I don't know if you've...
What you mean EPC, smart labels,
Yeah.
RFID?
No, not even RFID, but it's all about transparency, right? You could look at that smart label and you could see source all the way through, right? So that's the only initiative that I've seen, and that is a collaboration in the industry, but is not significantly penetrated, but it's a collaboration of sorts.
So I have just a little experience with apparel business. I think that the industries, every industry is different, every supply chain is different, and so when you get into questions about labeling, it depends on if it's consumer packaged goods, it might be a little easier problem to solve than, say, apparel. But there was a company that is based in Sweden called Looklit, and I don't know if a lot of you shop online for clothing, but a lot of the models that you see are basically they're cutout dolls, where they actually have photographs of all the faces, arms, legs, torsos, and everything, and then all the clothing is also photographed on green screen models, and then they can actually sit with it's a piece of software, it's CGI, and they can sit and make the outfits by putting all these pieces together. So you put, a blonde woman's head on a, white top with a black skirt and, different kind of shoes, and you can cut and paste all these things. And it's a really cool thing, and you'd be surprised at the number of websites that do this, because it's a lot cheaper than having to hire models and dress them up. So we used to have a studio in one of our warehouses, and I kind of got into this and started to study the business model. And what was happening is everybody that had a Looklit site, like in their studio, and there's not that many in the States, but they're all over Europe, would have to send their images to this company in Sweden, who would then have the database of the images. So it's one thing to have a barcode, like sharing barcodes across the whole supply chain. That's a challenge. But that doesn't help us, because we need to see the images of it. We need to know how to recognize it, and especially Tom when he's trying to pick it up. But that's the next level, is getting the images, and that's a whole different amount of data and much more complicated. Well, this company in Sweden, Looklit, was actually owning the data. So even though it was your dress or your skirt or your product, whatever, they own the image. And their goal was to actually monetize that business. I don't know how far they got, but it'd be worth studying, because I think what we really need is we need some sort of a repository to handle, so somebody that cares enough to get the image right so that we can use it in our world. So I thought it was a little bit complicated because everything was so much slower. We would take the image, we'd have to send it off to Sweden, and then we'd get it back 24 hours later. And we wanted to post it, our customers wanted to post it on their websites right away, but they wanted to own the data. So you really couldn't take it from the studio to the website. You had to go through them.
We're working on exactly what he's talking about, the cloud infrastructure of all the data, and it's a lot more data than I think we'll ever be able to put on a barcode, right? I mean, we're talking about megabytes.
I apologize for the barcode. I know that was
no.
simplification.
Your point is valid.
A common language for describing a box or a product.
Absolutely.
Mm-hmm.
I think it's key for the future.
Mm-hmm.
Okay. Yep. Thank you very much. I appreciate it.
Well, and thank the audience, and let's thank our panelists.